Spark today. So as most of you know that it is one of the very heavily used eco component right now. There is some reason behind that, why it is being used very heavily, and what is so special about Spark, and why is it dominating MapReduce to a greater extent. There are uh, uh, very good reasons for it. First, let's understand about what is Spark, and then how its architecture works, and then you will probably get to understand why is it a dominating component right now. So I would say Spark is an RDD based application. When I say RDD, RDD is nothing but resilient distributed data set. Okay. Anyways, we'll go into details of RDD after a little while. But Spark is an RDD based application, and when I have some input in HDFS, I wanted to process it. I can process it using Spark or MapReduce, right? You already know. When I say MapReduce, I can process it using Hive. I can process it probably using Pig. I can process it using a MapReduce program, right? So MapReduce falls under that category. And on the other side of the coin, you can process it using Spark. But what is so special about Spark is Spark does the processing 100 times faster than your MapReduce. It's definitely 100 times faster. Uh, the reason behind why Spark is 100 times faster than MapReduce is yeah, the reason behind why Spark is 100 times faster than MapReduce is the kind of processing that Spark does. We know that MapReduce is primarily a disk-based application, right? MapReduce always runs on top of disk, whereas Spark runs either on disk or on in-memory. Okay, Spark runs either on disk or on in-memory. If, for example, I have an input data set, I have to process it, and if that input data set is sufficient enough to be put into in-memory, it's gonna process entirely into in-memory. If it is something that has to be stored only, it does not fit into in memory, it's going to put that into HDFS, or your disk, I would say. But how Spark works, you'll understand it better when we talk about RT. But before that, Spark is not just popular because of its processing time. There is another reason why Spark is popular. Spark is a one-stop store for many things. For example, like I told, I wanted to transform the data, I would use Spark. Now, my requirement is to stream the data. That means I have to continuously get the data, I have to continuously transform the data, I have to continuously put it into HDFS or something. Spark will be able to do the streaming. Streaming is something that we already spoke about. And my requirement is, for example, I have some data on top of Hive. I wanted to query that. Spark will be able to do that for you. My requirement is I have some data in Hive. I wanted to query that data in Hive. Spark should be able to do that. And I wanted to run some machine learning on top of Spark. Again, Spark will be able to do that. So Spark is one-stop store for many things. So obviously people would get attracted to Spark because of its processing capability and its ability to do many things. So those are the two important reasons why Spark is so popular now. Okay, let's start to understand what is meant by RDD. Like I told, the full form of RDD is Resilient Distributed Data Set. So what does this resilience mean? Resilience means fault tolerance. Though I told Spark does the processing on top of in-memory, that that doesn't mean that you are going to lose some data because in memory is nothing but your RAM. Spark does make sure your data sets are fault tolerant. So it has four important properties called immutability, lazy evolution, cacheability, and tight inference. Those are the four important properties that Spark comes up with. But before we discuss about the properties of Spark, properties of RDD, let's understand what is an RDD. I understand resilience means fault tolerance. We know that distributed means distribution of the data. Data set means a file. So a data set that is distributed with fault tolerance is nothing but RDD. But you can ask me, hey, is it piece of the data or what is it? RDD doesn't actually represent the data. It's an abstraction of your data set which is split into multiple parts called partitions in your HDFS. For example, I have a file. That file will be split into multiple blocks, or in terms of Spark, I will call that as a partition. Right? We know that a file which is stored in HDFS will be split into multiple blocks or partitions. So that particular input file, when transformed, right, I'll get another input file. Again, another output file. Again, that file will be stored in multiple blocks or multiple partitions. How input got transformed to a new format, right? How this has been achieved is nothing but an RDD. It's not actual data. RDD is not actual data. It's an abstraction of your data set which is distributed into partitions. So it tells you how this input file can be generated as an output. That particular abstraction is nothing but RDD. Don't get confused that RDD is a data. RDD is an abstraction of your data set which is distributed across multiple partitions. And this RDD has 4 below properties. Immutability. Once I create an RDD, I cannot change it. For example, I have an input data set called A and I have generated B. Once B is generated, you can either generate C or D or E, but any of this particular operation cannot be changed. Immutability. Maybe if you're a Java developer, you would understand better about immutability. Right? Once you create it, you cannot change it. And second thing is lazy evaluation. This term seems to be like an drawback of Spark, from its appearance, but it's an actual advantage, I should say. What is this lazy evaluation? I'll first give you an example, and then I'll talk about lazy evaluation. For example, I have 1 million records data set. Okay, I've loaded that into an application. 1 million data set, I've loaded that into an application. After loading that into application, I was running some queries like maybe I wanted to apply some transformations on top of this particular 1 million data. And finally, my last command was to display at least 5 records. Okay. Now, what I've done is I've loaded 1 million records data set into an application. I've transformed record by record for all the 1 million records. And finally, what did user select? He has selected only 5 records. If I have known this user will be selecting only 5 records, I would have only loaded 5 records from my input data set to the application, and I would have processed only 5 records of that particular application. Why do I have to process the entire 1 million records? That's the point here, right? But I will not get to know until my last command comes what is my user's expectation. Is he requesting all the 1 million records, or is he selecting only 5 records or 10 records or whatever it is, right? So Spark has 2 important things: transformations and actions. Transformations are nothing but you have an input, you're generating an output. That means you're transforming the input to an output, right? So that's a transformation. What is an action? Action is nothing but when my output got generated, how many records are there, count or selection or entire storage. All these are actions. Though I would talk more about transformations and actions after a little while. That's what an action and a transformation is. Action is an action that you are performing on top of your RDD, which might give you the count of records, or you're selecting the few records, or you're saving your data set. All these comes under actions. When I have to talk about transformations, I have an input data set. I'm transforming this input data set to a new format. maybe splitting the file, maybe grouping by key, maybe join by a key or something. So all these comes under transformations. Now, in my earlier example of 1 million records, I got to know that my user is selecting only 5 records when I encountered action. That means he's selecting something, selecting 5 records. Only then I'll be able to understand whether a user is asking me 5 records or 50 records or 500 records. Right? Similarly, even in Spark, you have two things, transformations and actions. So you'll obviously get to know when actions are being published, what is the user expectation. Right? So when it comes to lazy evolution, what happens is all the transformations will be syntactically checked but executed only when it encounters actions. That means when I spoke about 1 million records, all the 1 million records are loaded, right? I've traversed record by record, right? And then I've transformed record by record. At the last, user had selected for 5 records. Take that example. Now, what Spark does is all the transformations and everything that you are applying on the 1 million records, it will syntactically check it whether the command that is given by the user is syntactically correct or not. But execution, it will not do until my last command comes, which is my action. So when my action comes, I will get to know whether the user is selecting 5 records or 1 million records or what is my user asking. I will get to know, and then I'll start the execution. So I unnecessarily need not have to work on majority of the data, because in majority of the queries you would select a random data or something. You need not process all the 1 million data or 1 billion data or 1 trillion data, whatever it is. So that's the advantage of lazy evaluation. Lazy evaluation is something with respect to Spark. The execution starts only when the actions are encountered, but transformations are only syntactically checked. Okay, that's about lazy evaluation. And the third thing is cacheability. Cacheability is nothing but if you want to store the data, I'm generating some new output. If I wanted to store the output into an in-memory, I can do that. For example, I'll tell you this. Maybe Lakan is working on a framework, right? Lakan is working on a framework which is generating some output. The output that Lakan is generating is something that needs to be viewed by many people. For example, LT wanted to take this as an input, and maybe Hammond wanted to take this as an input. So this is a kind of output that Lakan has generated, the kind of output which will be referred by many people. If Lakan stores that into disk, right, it will take a lot of time to each person to go to disk and take the data and query it or whatever it is. Rather, if he caches that into in memory, everyone can look at it fast. So that's the advantage of Spark. Spark can make its RDB to be cacheable into an in memory. Or if you want, he can process the data into disk also. So I'm using two terms. One is caching and another thing is persisting. Caching is nothing but you are putting the data into in memory. When I'm using the term called persisting, I'm storing the data permanently on top of a disk. So these are the two terms that you would be regularly having across when you are talking about Spark. Cacheability and then the persistence. So he can do either way. Based on his requirement, the user can either cache the data or persist the data. And finally, type inference. Type inference is nothing but when you are writing some applications on top of Spark, you need not bother about the type of the data. Right? You need not at all bother about the type of the data that you are handling. So type inference is nothing but Spark will assume everything as series of bytes. Right? There is no string, there is no int, there is no any other data type. Everything will be assumed to be series of bytes. That's how Spark will assume your data sets to be. Okay. I hope everyone is clear so far. Any questions? We'll stop here for 2 minutes. Unmuted. Yes, Mukul, go ahead.
Surya, please explain the last property type inferred. I couldn't understand it fully.
No, simple, Mukul. You're trying to load a data set into Spark, okay?
Okay.
And that data set has different columns: column 1, column 2, column 3, column 4. Okay, and column 1 is of integer, column 2 is of string, column 3 is of probably double, column 4, 5 is of float or something. When you load that into Spark, Spark only treats them as series of bytes. Everything is series of bytes. It doesn't bother really about your data type. That's what type inference means. Got that?
Okay. 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 And what is the use of immutable property? Yeah, I mean,
Immutable property is nothing but once you create something, you cannot change it. You'll understand that because see, uh, there is no confusion. Spark has something called DAG. DAG means directed acyclic graph. Okay, let me put that in an Excel or something, then you will understand it better. I understand. I know that DAG exponentially, there's immutability might little confuse you. What is the advantage of having it? It's simple.
yes.
When I say Spark execution is DAG, directed acyclic graph, that means if I start at a point A and then I've gone to point B and then I've gone to point C, then I've gone to point D and then gone to point E. If you could see here, nowhere there is a loop back. Everything is directed acyclic graph. That means it is straightforward and there is no bicycle. That means there is no loop back. I have gone from A to B, B to C, C to D. Did I ever come back, go and check what is B?
No.
No, right? I'm just further. That means when I create something, that is created and I'll proceed further. I'll not come back. That means if I cannot come back and change it and do some modifications or something. If I create an RTD, that is final. Okay, and you are proceeding with next RTD. I'm not going to come back and check what it is. Right? This particular, loop backs are not there with Spark. That's why the Spark execution is directed acyclic graph. You are only proceeding in a forward direction. That's what it means. And when you have a DAG, obviously when you are creating RGBs, you are expecting that to be immutable. Got that, Mukul?
Yeah, okay. Thank you.
Yes.
You did.
I see a few other hands raised. Hammond. Yeah, Hammond, please go ahead.
Could you go to the other slide, please? The main.
Okay.
Yeah, you said type inferred means that everything is converted into bytes,
Correct.
right? So what is the use of this? What is the advantage of this?
See, you need not bother about typecasting, right? So that's a biggest advantage. When you look at MapReduce or something, you always bother about your data types. Not just about MapReduce. You take any programming language, you always bother about your data types. But here in Spark, you need not bother about data types. When you are treating everything as stream of bytes, you can process them all together. Especially if you want some typecasting or something, you can do that. But Spark internally treats everything as stream of bytes, which saves a lot of time for me in typecasting or probably the data type decision, all these things. These won't be there, right, anymore. So that's an advantage.
Right. So internally, okay. So from our end, it is very easy. But we have data types for a reason, right? Like we allocate data in the memory, like specifically say integer has 4 bytes, something like that.
Correct. Correct.
So how does it manage it internally?
All it matters is your HDFS block size, right?
Right.
All it matters is HDFS block size. When I'm having a file of certain data, it shall have some certain space. That particular certain size will be occupied in your HDFS. So anyways, I'm already storing my data. See, one thing you have to understand, Spark is not a storage layer. It already works on data stored somewhere. So why does it have to bother about its memory? Because you have HDFS who is taking care of the blocks and all the block management is taken care by your name node. So Spark need not bother about your from memory allocation or something. What it does is it simply stores data somewhere in HDFS and HDFS takes care of block management and the memory management. Right? Okay. It's as simple as that.
Got it. Thank you.
Is it advantage of having DAT? Of course it is. Because see, your execution is not complex, Mukesh. Or I'm not sure. Mukul or yeah, Mukesh. Your execution is not complex, right? I mean, uh, I'm not confusing my algorithm. When I start somewhere, I'll keep on proceeding further, and I don't have a loop back here. So if I say you, hey, we are going to do a lot of things here. Uh, if I say I'll go to A, I'll go to B, and then I'll come back to A, and then A to C, I'll jump, and from C to D, I'll go, and D to B, I'll jump. I mean, that's a complicated way of execution, right? So Spark doesn't want that. It's a simple, straightforward execution. DAG, directed acyclic graph. The same holds good for your Uzi as well. And you're scheduling any jobs, you go from one direction to another direction. I mean, you don't come back. That's why acyclic means you're going on a single cycle. You're not coming back here. So that's a definite advantage. You'll understand that. I'm going to talk about Cloudera documentation. You'll understand more about the advantages of DAG. Right, Mukesh? And SLT, please go ahead.
Spark and Hue both are same, but it's different.
Spark and what was that? Hue.
Yeah.
Hue is just an web interface tool. If I wanted to use some kind of queries on top of Hive rather than logging into Hive shell, I can execute it from Hue. Hue is just a web interface tool.
Oh, it's only web interface tool.
Yeah, Spark is an application.
Okay. Thank you.
Just like Hive or Pig, Hive or Pig or Scoop, Spark is another echo component of it. Same as Hue also, but Hue is a different story. It is for execution. It's a web interface tool. That's it.
So the pig is also same like Hive and Spark.
Yeah. But see, Pig is again a map reduce component just like Hive. Anyways, I'll talk about that. But Spark is more popular now, and it is dominating your Pig and map reduce to a greater extent.
Okay. Thank you.
So now, Spark again is just an execution engine. If you ask Spark to take care of cluster management, it's not going to take care of it. Because, see, people keep on saying Spark is dominating Hadoop. See, Spark wouldn't have got so much of prominence without Hadoop because Spark is running on top of Hadoop at the end of the day. And the underlying architecture that Spark using is its own architecture, RDD. But for RDD to execute, the cluster resource management is being done by Yarn. Yarn is what? Yet another resource negotiator, which we already know totally about. So when a Spark driver, for example, let's say Latin has written some program and they submitted it. Okay, and that's an application. When he has submitted an application which goes to your resource manager, and resource manager takes all the burden of calculating all the resources through its application manager, application master, and it gets the resources and gives it back to the Spark application, which I call it as a Spark driver. But who is taking care of this cluster management? It is being done by the Yarn, right? So Spark runs on top of Hadoop, and it uses Yarn and gets executed. And Spark can also run standalone, but again, cluster resource management has to be taken care by someone called Mesos or something. There is an resource manager called Mesos, which is out of Hadoop basically. So when with respect to Hadoop, when Spark is running, the cluster resource management is being taken care by Yarn. You have to remember that. Okay. So Spark is something that executes, that takes care of the execution, but resource management has to be done by someone who is nothing but your your Yarn. This is something that you should be clear with. But anyways, I will talk more about how Spark driver and master works and what is the significance of the driver or master. But when the application goes to your resource manager or something, the data nodes, the container calculation and container allocation, everything will be taken care by Yarn. That's something that we already know, which we have already discussed. So Coming back to the transformations and actions, I told you when an RGD is there and when a new RGD is being generated, that is called a transformation. That's clear, right? When I have a data input and when I'm generating the output, that I'm transforming input to output. That is nothing but transformations. Actions are something that you are selecting some data or counting some records or you're storing the data somewhere. All these are actions. But as I told, Spark has lazy evolution. And I say lazy evolution, the transformations that you apply are just syntactically checked, and the actions that you were talking about are something like will get executed. The actions are something when a Spark encounters actions, only then the execution will start. Until then, your transformations will be just evaluated. Yeah, I mean, you have RDT1 and you have RDT2. You're applying a transformation for RDT1, you're getting RDT. And RDT2, you're applying another transformation, you're getting RDT3. And on top of RDT3, you're applying some action. That's when the execution starts and gives you the output. Until then, your RDT1, RDT2, and RDT3 will be syntactically check whether their syntax is correct or not. Okay? So that's the whole story about transformations and actions. And what is this count, sum, collect, or map, or a filter, or reduce? We will see that when we are actually using the practical, when we are actually discussing about the practical version of Spark. But I have something to discuss here. I have RDD1. I've got RDD2 generated, right? And this RDD2 will be used to generate RDD3. Something like that. It proceeds so on and so forth. For example, like I told, RDD2, whatever has been generated, it's something referred by many persons. Let's say if I've generated it, if let's say Hemant is referring to it and Lakshmi is referring to it, so many people are referring to it. So I can cache this RDD2. I can cache this RDD2 into my in memory. And maybe, okay, I'm referring to RDD2 and I'm applying some transformations on top of it. I've got RDD3. Okay. Now RDD3, I can save it on top of disk, right? And RDD3, I can save it on top of disk. I persisted on top of HDFS. Okay, that's fine. Now my RDD1 and RDD2 are lost because those data nodes are down. That is fine because I've already got my RDD3 on top of my HDFS, so I'm happy enough. I need not bother, right? Because when I'm storing something on HDFS, my data gets replicated into different blocks. So I'm totally happy with it because even if one data node goes down, there is another data node which can give me the data. So I'm perfect here. You can ask me, hey, what if I don't store any of the RDD into my disk? What happens? That's fine. When RDD1 is used as a reference to generate RDD2, RDD2 to RDD3, let's say all the three data nodes that are storing all the RDD1, RDD2, RDD3 are down. That is fine, no problem. What is RDD? RDD is an abstraction of your data set. It's not actual data. It tells you how RDD1 got transformed to RDD2, how RDD2 got transformed to RDD3. It's a matter of transforming the data once again. That's it, right? You are not going to lose the data when your data nodes are down or something because RDD is nothing but an abstraction of how RDD 1 to 2 got generated, 2 to 3 got generated. The commands are nothing but, the abstraction is nothing but RDD. So if something is down, I will recalculate. But how that will be recalculated is something that we will be discussing in another presentation, and I will term it as lineage. When someone talks about lineage or something, that they are referring to nothing but, hey, when some part of your data is missing, how is Spark reconnecting that? How is Spark recalculating that? That is nothing but lineage. So we will discuss about lineage now. Wait, not just about lineage. I'm going to discuss about a particular presentation that I've got from Cloudera. Okay, I don't want to share this because it's a kind of a confidential document or something. So I'll just run you through this document actually. Okay. So okay. So I'll just I mean, it will also have the same concepts that we have discussed in the slide, but it will have more details than what we have had in our slide. Spark is a flexible in-memory data processing for Hadoop, like you already told, and it is easily deployable, flexible API. Like I told, you can do the batch processing, streaming, you can do the machine learning. You can also use it for graph, but people don't use Spark for graph analytics or something. Rather, they will go with a Tableau or something which does the visual analytics. Fast batch and stream processing because you can in-memory processing and caching is allowable. I mean allowed in Spark because of which it is very fast. This is something that we have already discussed. Easy deployment, rich APIs for Python, Scala, or Java. One has to remember that Spark is developed on top of Scala, the functional programming language. But having said that, Spark doesn't ever have any language barrier. You can either develop your Spark components on top of Python or Scala or Java. So Scala and Python are the most preferred programming languages for Spark development. And in this course, I'm going to talk about Spark using Python rather than using Java. But if you are someone who is interested more on Scala, you can probably just learn the programming interfaces of Scala and then start working on Spark. The commands, whatever I'm going to talk about on top of Python, that would be very similar to your Scala as well. Okay, so it's a matter of learning Scala and implementing it. But again, like I told, there is no language barrier with respect to Spark in the current market. Okay, so why Spark? It's kind of slide that tells why Spark is popular, right? I mean, it's the most active project in an Apache Standard Foundation. For 40% of more activity than core Hadoop, and 170 customers are running Spark on their production. Adoption across all industries like healthcare, finance, and retail, etc. So all this talks about the popularity of Spark. Customer uses how customer is using Spark, something online fraud detection, instant prediction for sepsis, online recommendation systems, real-time inventory management. All these are the customer use cases on top of Spark. Okay. So yeah, this is what I was talking about. RDD, resilient distributed data set. What is that resilient distributed data set? I already told. It's an abstraction to represent large data sets, large distributed sets of data that are being processed. And by the told, these particular data sets will be distributed into partitions, right? So Spark is fast because it's it's doing the processing on top of in memory, but it is doing it in parallel again, just like any distribution framework that you have learned so far. I told you, right? I mean, we achieve parallelism on top of it, same as Spark as well. The partitions that are there for RDD are operated upon in parallel. Like if an RDD has 10 partitions, all the 10 partitions will be operated in parallel. And like I told, it is immutable and fault tolerant. Fault tolerance it is achieving with the concept of lineage, like I was discussing it a little while ago. So I will talk about lineage in my next slides. So that's the story about RDD. RDD is not actual data; it's an abstraction of your large data sets that are distributed into partitions, right? And these partitions will be acted upon in parallel, and these RDDs are immutable and they achieve the fault tolerance. So that's the whole story about RDD. Okay. I hope everyone is clear so far, right? I mean, Scala itself is another programming language. Scala is just like your how you develop your Java components. You have to use, I mean, just like your Java. In place of Java or Python, you can use Scala. Scala itself is a programming language. Will we be learning it? Of course, we will be learning it. We would uh, uh, will be learning HBase after Spark, and after that I am going to talk about Kafka and Flume, and then I'll be talking about Pig. So we will be learning Pig. What exactly is abstraction of large data sets means? It's simple. Like I told, you have input data set and you are generating output data set, right? How are we generating input to output? Maybe a transform. And as I transform the input to output, what I would say is I've applied some, probably you are taking the input line by line. What you're trying to do is you're trying to trim up the spaces and then you're splitting the columns, and out of that you are storing the output in the column for only the columns that are required or something. That means you're transforming input to output. Okay. So that means when you're transforming input to output, you have applied some transformations. So those transformations are nothing but your abstraction. That means it tells you how to generate input to output. Okay. That's what means the abstraction. How the partitions can be on Spark. It's just like your blocks, right? Each block is a partition for Spark, right? So when I have an RDD is stored in HDFS, right? When I have an input RDD or something, which is there in HDFS, that HDFS will offer you blocks. Each block is nothing but your partition. Okay. Now, so I spoke about RDD here, and like I told, there are a lot of transformations that you can apply on top of Spark, and there are a lot of actions that are there on top of Spark. So whatever are there in colored in black are nothing but your transformations. Whatever are there in this blue color are nothing but the actions. Okay. So we will work on this anyways when we are talking about the practical implementation of Spark. Logistic regression, a simple example of logistic regression which is very heavily used in very heavily used in machine learning. How easily can we implement logistic regressions on top of Spark is something that they have shown you here. It's a Python code, a simple, oh, it's in Scala code, sorry. The simple Scala code, oh, I'm sorry, it is a Python code, right? It's a Python code that I've noted here, that I've put here, just to signify you how the logistic regression can be easily achieved using Spark. Now, the actual internals of Spark starts here. Like I told, Spark jobs are DAGs, directed acyclic graph. I already told you I have A, I'm going to B, and B to F I'm going, and I have C, C to D, D to E, and then did you ever see that I'm coming back or something? No, right? Maybe F and E I'm joining, and finally I'm generating G or something, but never a loop back. That's what means by DAGs, directed acyclic graph. And all these are like operations on top of RDBs. When I say A to B, B to F, these are operations on top of RDB. So there are two types of operations on RDB, which we already discussed as transformations and actions. When I have an RDB generating a new RDB, I'll call it as a transformation. Running computation on top of an RDB, just like counting or doing a sum or returning a value, saving it somewhere, saving the RDB somewhere, it is nothing but the action like you already know. So transformations when you write, they will be just syntactically evaluated. When you encounter actions, that's when the actual execution starts. That's the whole story that we have already discussed about transformations and the actions, right? Now, see here. When I write a Spark application, right, when I submit a Spark application, who will take that application into a resource manager? There is nothing that is nothing but driver. There is something called a driver, which is also referred as a master, and there are something. For example, a person who submits a particular application, right? Application. When a person submits an application, then that application will have a driver code. Driver code is nothing but something like a main function of your static main in Java, right? That's when the execution starts. Similar to that, the driver is something, there will be one for every application that you are submitting, which takes your code to your resource manager. And whatever nodes resource manager is offering back, those are nothing but the slaves. So the driver, I can also call it as a master, and the nodes that the resource manager is giving you can be called as the slaves or worker nodes or executors. Okay. So why do resource manager give you certain data nodes? Because they would have the data that the driver wanted to process, right? So they are holding the partitions. One has to understand why would a resource manager give certain data nodes to a particular Spark application? Because Spark application wanted to process certain data. That data is present in those data nodes in partitions. So it is nothing but when an executor submits or a driver submits and not executors, I'm sorry. When a driver submits a program, it goes to resource manager. Resource manager gets you the data nodes, which is nothing but the executors or worker nodes. These executors or worker nodes are nothing but the ones who hold the RDD partitions. Okay, now look at the Spark internals. Driver is one driver per Spark application, runs the main function of your app, creates a directed acyclic graph and physical execution plan. What is this physical execution plan and schedule task? I'll talk about that in my next slide. But right, so main driver program or the master are the ones who holds the main function, who takes your application to the resource manager. And resource manager, the data nodes that are given by the resource manager are called executors or worker nodes. And the executors or worker nodes are the ones which hold the RDD partitions. And how to execute and everything will be told to the executor by the driver. I mean, the tasks that the executor has to perform will be scheduled by the driver, how to execute and everything. So that is nothing but the physical execution plan. You will understand that, right? So going back and going to another slide further, there is something called a Spark context. Like I told, there is a driver program or a master I was talking about, right? So this driver or master will be called as Spark context in programming terms of Spark. Okay, that means the Spark context is the entry point of Spark. For example, let's say someone wanted to write an Spark application. The first thing he has to do is he has to create a Spark context because he is the master or the driver, right? It is the entry point of Spark. One second. It is the entry point of Spark. From there, I go to the executor nodes, and once my resource manager gives, I'll get the a worker node, and I'll execute my task, whatever it is. Okay. But one has to remember that driver programmer main is nothing but it is signified by something called Spark context, which is the entry point of Spark. If you are trying to write an application on top of Spark, the first thing that you do is programmatically you create a Spark context. Okay. One second. Yeah. So when you are trying to write a Spark program, the first thing that you create is Spark context. Okay. Now, what is this physical execution plan or logical graph? It is nothing but, see, I wanted a program to be executed. Don't get confused with too much of details here. Don't concentrate on this particular picture. You'll get confused. I'll tell you what. I have a task to be accomplished. Okay? When I have a task to be accomplished, I know that I have to work on the data nodes, which I also call it as executors, right? So, when I say I have an execution to be accomplished, okay, when I have an execution to be accomplished, I have to execute something on top of my worker nodes. Worker nodes are something. Worker nodes are nothing but the data nodes which are holding the blocks of your data, right? So keep that in mind. Now I will just give the insights of this bit on a high level, and then I'll stop it here, just not to confuse you more. If a transformation is being applied from A to B, I told you the transformation will be applied on top of partitions of your RDD, right? Because your RDD is split into multiple partitions, and these partitions will be operated in parallel. So a particular logical graph or execution graph is broken into states. Each stage consists of multiple tasks. A task is a unit of computation that is scheduled on an executor. A stage consists of multiple operations that can be pipelined. See here, if you look at here, I would say there are two stages. The top portion is stage 1, the below portion is stage 2. And what had happened? Each stage is divided into multiple tasks, right? So if you could see here, A to B is one operation on top of which you will have multiple tasks. Like I have this particular partition which will be transformed to this particular partition. This particular partition which will transform to another particular partition. That means I am operating on part of my RDD partition wise, right? That's what is nothing but your task is. A task is a unit of computation that is scheduled on an executor. So transforming this partition of A to this particular partition B is nothing but one task. That's what it is. An execution graph is broken into stages. A stage consists of multiple tasks. That's correct, right? I mean, I'm having multiple tasks here. Transforming this partition to this partition, this partition to this partition. Similarly, in this case, C to D and D to E. All these are a particular task that are being accomplished. What internally this task does, that could be a different story. Maybe a map, maybe a filter, maybe a group by, maybe a join, many things it can be. But it's a task that is being performed by the executor. Okay, that's a high level overview. Probably I don't want to confuse you more on this. Just I'll wait here for 2 more minutes to answer all your queries. Do you have any questions so far? Anyone? Is everyone comfortable? Can you confirm that, please? Whatever we have discussed so far. That's it, please.
I have questions on the other one, that scoop command that we were talking.
Oh, double hyphen, right?
Yeah. What is the significance? Sometimes double hyphen, sometimes single hyphen.
No, every time you will pass double hyphen. I mean, it is a matter of passing arguments to your scoop. That's it.
So any command means you have to put double hyphen and any value passing or limit.
No. I'm passing double hyphen connect, right? And then I'm passing some JDBC string or something. So double hyphen connect is nothing but the parameter that I'm passing to. The double hyphen connect is the parameter that I'm passing to my scoop command. Okay. Value comes immediately after the parameter. Double hyphen command and connect, and then immediately I'm just putting in some double quotes and I'm giving some value, right?
Yeah.
So that's a value. For value, you will not pass hyphens or something. For your parameter, you will pass double hyphen just to say that it's an argument to scoop. Okay. And see, usually in programming terms, when I have a lengthy string, I use double hyphen. When I have a single character like A or a simple B, I use single hyphen. And that's how it is in programming standards. To signify your arguments, they will use for single characters to pass a command. You will pass hyphen, single hyphen A, and then some particular value. If you are passing some strings like a command or a connect or something, double hyphen connect, double hyphen table hyphen name, right? That's how the particular, I mean, because table hyphen name, it's nothing but two different words. I could separate them, they would be using hyphen. I mean, nothing more significance on top of it.
Okay. Yeah, because normally for the comments we put in double dash like that. So
I
yeah,
understand.
I thought something. Okay, thank you. Yeah.
See, is there anyone who is pending with installation? See, if you are not able to do the installation, it's simple that you are not following the commands properly. You have a video to refer. You have an PDF document to refer. You can sync both the video and PDF, and you have to just do the steps of installation. But still, is there anyone who is still missing doing the installation? Installation of Hadoop? Yes, Lakshmi, that's what. See, I mean, when I give you the access permission, I'm able to do that, which means that there are certain things that you are missing there. So just follow the video perfectly. You will be able to complete the installation, right? I think everyone else had completed the installation. Okay? Yeah, please refer to the video and then up to the doc parallelly. You should be able to complete. Yeah, and sure, Mukesh. And another thing is this Spark, right? What I would do is you just try to understand some basic aspects of Spark that we discussed today. Because tomorrow I wanted to talk about execution plan, which might be little more on what we have discussed today. So just to not get confused, just give a read or watch this video once again to understand all the basics that I've discussed so far. Because there's a lot of new jargons that I was talking about, RDDs and lazy evaluations and something. So get these topics understood so that you would have some clarity when we talk about the execution plan. Because the execution plan, I don't want to spend more time on it. I will take hardly for 10 to 15 minutes, and I wanted to go to the practical aspects of Spark, right? So, yeah. Yes, Mukul. Unmuted. In minute. Is that what again you wanted to convey?
No. So for Hive, I have been using CDH 5.5, but it's very heavy. So my virtual machine
What's
is
what's the RAM you are using?
8 GB.
Okay, 8 GB should be fast, right?
No, I mean my laptop RAM is 8 GB, but that version 5.5 requires minimum 4 GB RAM.
Yeah, that's what. I mean, you already have 8 GB RAM, so that's fine.
Yeah, but it's still running slowly. So is it okay if I?
One thing that you have to do is you have to close all other applications that are there on top of your Spark, and then I mean all other applications that you are there on top of your laptop, and then start running the VMware. Then it will run faster.
Okay, then is it okay if I run Eclipse in the VMware alongside the Cloudera 515?
Yeah, that's what that means. Don't open too many things because here I'm able to open everything because I have 16 GB RAM.
Okay.
Right. So the thing is, when you don't have sufficient RAM, close your Chrome, everything you have to close, and then you open your VM workstation. Then it will be fast.
Okay. Thank you.
And mostly another 10 to 11 sessions more, maybe 10 to 11 days more for our discussion. And lineage, yes, I've not covered it today because it looks little complex for you to understand all the aspects in a single day. So I'll cover the lineage or how the missing parts will be calculated. I will be talking about that tomorrow. That's what the internal execution when I was talking about. I'll be talking about the lineage as well. And sure, Drew, I can send it. Probably, can you drop me an email, please? I'll send it across. Okay, guys, that's it for now. Thank you so much, and good night. Bye bye.